Hello everyone, in this video I'll be explaining you the third problem, maximum score after binary swaps, and it was asked in lead code biweekly contest 172. So let's read out the problem. You are given an integer array nums of length n and a binary string s of same length. So string length is also n only. Initially your score is 0. Each index I, where s of I is equal to 1, contributes nums of I to the score. Okay, so understood. Okay, it's like whenever s of I is 1, so that uh, corresponding index in the nums will contribute to the score. So you may perform any number of operations including 0. In one operation you may choose an index I such that it is 0 based indexing. That's why I is greater than equals to 0 less than n minus 1. Okay, so where s of I is equals to 0 and s of I plus 1 equals to 1, and swap these two characters. Got it. So we can swap these two characters if this condition is valid. I'll tell you on the board, don't worry. So return an integer denoting the maximum possible score you can achieve. So at max, what is the possible score that we can achieve? So we need to return that. So we have 21523. Let's go to the board and look into examples. This is nums, and string we have 0101. This is a string. So let's understand the problem statement, what they're trying to say. They'll give nums uh, array or vector, you can say, and whose length is n, and they'll give string s. This is string whose length is also s only. Sorry, n only. So initially our score is 0, they're saying, and we need to maximize the score. And which elements will contribute to the score? So the index where s of I is equals to 1. If that is the case, then your score is going to increase by nums of I. So this particular index will contribute to the score. So this problem would have been straightforward if only this was the condition, because wherever s of I is equal to 1, you just add to the score. But the interesting thing is they have added one operation, and this operation is, if you find s of I is equals to 0 and it's not like or something like that, and its next index is 1, so we can swap these two characters. Swap this character in a sense, s of I is going to be 1 and s of I plus 1 will go to 0. So this operation is important, and let's try to understand. Okay, so if you see this problem as a straightforward, so see, initially your score is 0. Now at this first index, s of I is 1, so add 1. At third we have 2, so your score is 3. So is it the maximum possible? No. So what we can do is we can swap these two, because s of 0, s of I is 0, and s of I plus 1 is 1. It's like I is here is 0, 0 and 1 indices, 0, 1, 2, 3, and 4. These are the indices. So this condition is holding good. The current element and the next element are holding this condition, like s of I is 0 and 1. So we can swap these two. If you swap these two, your string will look something this way. So now let's try to find the score. Now if you find initially score is 0, so at first index it is 1, so take 2. Initially here it was 1, now you're taking 2, so 1 score is increased. So obviously this would be maximum, maybe, we'll see. Now the third one is again still to take it to score is 4. Okay, so now and they've said this operation you can perform any number of times. It's like you can perform zero number of times also. In some of the test cases they may give one in a place where if you add those elements your score is maximum, so in that case you will need to perform zero operations. So see this one, if you keenly see, it cannot move forward. One cannot move forward, one will only move backward, and the zero will move forward. So this one's possibility was only one at this position, so we have made from this to this and we have done it. Okay. Now this one, its possibility are now 2 because there are two zeros, so it may move here and here, right? So these are some certain observations that you need to keep in mind. So let's see, we will try to move it this way. Here it is 2, here it is 1, here it is 5, right? In this 3 position if you see, so which is maximum? 5 is maximum. So we'll try to start this because it holds condition s of I is 0, s of I plus 1 is 1. So your string is going to be this thing. Now your score, if you see, it is going to be, initially it was 0, 2 you are adding, then at second position we have 1, so 5 you are adding, so this is 7. So among these three, obviously this is maximum, and this is our possible, I mean, answer to this question. Let's see other test cases. Okay, in this case all are 0, so score is 0 only. Okay, so let's try to understand again this deeply. So yeah, as I said, one of the observation was that this one, it has the flexibility to move only backward, not forward, because uh, in operation they have said if s of I is 0 and s of I plus is 1, if this you are seeing only, you can swap it. Let's say you had this way, so these two elements you can't swap. Okay, because we are not allowed to swap, and these two elements also we are not allowed to swap. Reason being is s of I is 1 but it should be 0. S of I here, it is 1, it is not equal to 0, it should be 0. Okay, so 0 1 if you see, you can swap. 1 0 if you see, don't swap. 0 0 if you see, don't swap. 1 1 if you see, don't swap. Even if you swap these two, there is no meaning, but still I'm just making a pattern. Okay, so yeah, only if you see this you can swap. So when you're swapping this one, it is moving backward. Let's say you had like this thing, so when you swap these two, one is moving backward. Now still you have 0 1, again it will move here, it can move here, so this is the final after this. So your 1 is always moving backward and your 0 is moving forward. So this is the observation wherein you will find the answer. So here when you saw 1, so its subdomain is this thing, this much, so it can move, I mean this one can move, uh, it can be at this position, it can move here. So why do you want to move it here? The reason why you want to move it here, because you want to find the score maximum, you want to increase score maximum. In order to increase score, the element that you are choosing has to be maximum. So among these two, this is maximum, that's why you have moved it. Now remaining you just write it, so you swapped. Now this one, it can move to the here and here, and not more than that, because it will not go anywhere. So among now this is over. So among now these three, which is maximum? 5 is maximum. So it will try to move here, so you just swap it, so you have got this score. Okay, so we'll have to look at this way. So I'll try to tell you still more test cases. it? Let me write 8171. Three, 7, 5, 6, 10, 10. And let me take one more test case. 5646, 10, 3, 2, 2, 6. So yeah, let us take some test cases. So in this case also, sorry, I have not taken 001, 011, 1000. So yeah, this is the string. Now if you see, we have one net here, right? So which means these three elements in which is the maximum, there one can move. So this is maximum, so I'll try to move it at this position. So we have swapped this. I mean, first time we have swapped, second time we have swapped. So it is the final value. Now remaining this value, you just write it. Okay. So your score is currently 8. It was 0. Now it is now 8. Now this one, it can take these 4 positions. So it can take these 4 positions. So which is maximum? 7 is maximum. So I'll try to move on at this position. I have moved 1 at this position. Okay, and I've added 7 to my answer. Now this one, okay, till this we have, now this one can move these 3 positions. It can move these 3 positions. So which is maximum? 7 is maximum. I'll try to make this one stay there only. Now this one, it cannot move here because we don't have zeros. Since this I mean, this was the one wherein it did not move somewhere, it was maximum only. So it may happen that here we have element which is greater than at this position. So this is the example when I'll show you. It's like, let's say 7 we have here, but instead of 3 we had, let's say 6. So in that case, if we have chosen this 5, so which is lesser score, right? If you choose 1, this is correct. So in that case, I'll tell you how to do that. So it's 3 right now. So we'll be choosing 5 only. So we have chosen 5. And we don't have anyone, so its answer is 15 plus 5. It is correct, right? 8 plus 7 is 15 plus 5 is 20, but its answer is, I think, this one. Its answer is 27. I guess somewhere we have missed it. 8 we have chosen. I think we have chosen only 3 values, 8, 7 and 5. Actually there are 4 ones, so one more we are missing. Okay, first one, it was, we have chosen this one. Now the second one was at this position and we have chosen 7. Now we have 2 remaining. So one more 7, I just missed it, I guess. So we'll have to put it 7. So 20 plus 7 is going to be 27. So yeah, this is perfect. Like I just missed one number. So in this way, you solve it. Now let's try to take this example, and its S is what? Its S is 0 1 0 0 1 0 triple 1. So yeah, let's see. um, Initially your score is 0, so we have 1, so it can move to these two positions. So let r1 is here only, so you are adding 6 to the score. Now we have 1 again here. Okay, so it's like among these three, the first two values here, among these three values 10 is maximum, so I'll make sure 10 is here only, so I'll add 10 to the answer. Now we have one more 1 here, so it is like here. So if you choose this 3, your answer will be less. The reason being is, what if you choose, instead of 10, let's say you choose 6. So if you choose 6, okay, so now you have these two elements, right? In these two, maximum is 10, you can choose this. Okay, it's like you are leaving this 6, you are choosing 3, so 3 was lesser, so I will try to choose this. Next, in this 2, uh, yeah, it's like we have 2. So again, if you choose 2 comma 2, so which would be, lesser. So I think whatever maximum we were choosing, it was not correct. So from this example, we come to know that whatever maximum we are choosing, it is not correct. So how do we choose that? So so now the problem approach or changes to be this way. See, uh, till here, whatever element is there, you just uh, keep track of what is the maximum element. Okay, now when you're choosing the next, like maximum element, whatever is there, you just choose that. You have chosen this maximum element. Now till here, you will be choosing, right? So till here, what is the maximum element that you need to choose? The reason being is, as you saw, when you were choosing this element, right? So let's say you have chosen this 10, and now since from these from this element, if you try to choose, only element from these two, your answer is not valid. So you'll have to choose from remaining 5, 4, 6, 3, 2, which is maximum. 6 is maximum. So 6 maximum means you can move this one to this position and this one to this position. It's like you are at here only, but this one could have not been moved, but you can make these two move, so it will become 1 0 and 0 1, and you can move these two here, I mean these two here, sorry, it is here like this, so you can move these two here, so it is going to be this thing. So always what try to do is, till 1 whatever you find, I mean you take these elements and put it in a set or somewhere which keeps track of maximum element, and when you find that 1, so this one you cannot make it to move this side, right? It can be moved to the leftward side. So in which position will it move? It will move to the highest position. So once you found that highest, you that remove from the set or remove, make sure that that element is taken care. Now you have removed that. Now whenever you are finding this 3 element, I mean 1 at this position, now the next greater element whatever you have, you will choose that, so that your answer will be maximum. Okay, now here you have 1, so again it will expand. So the next greater element, if you see in this, it is 5. So it's like whatever 1 you have chosen at this position, it is not. 1 will move here, and this one will move here, and this will move here, and this one will move here. So it's like pushing forward. Okay, and at the end again you have 1, so you'll expand your boundary. Now from these elements, which is maximum, this is maximum. So the maximum score from this, if you see, it is 11 plus 6 is 17, 27 plus 6 is 33. So here your answer is 33 only. So I think you have understood what we have to do is, it's an easy only. Basically, you you need to put these elements in a set and try to keep keep track of the maximum element. So once you find this one, so whatever element till one you have found, so among that which is the maximum, place that one to in that uh, position, swap in that position, so your score is maximized. It's a greedy approach only, greedy problem. Now again you move forward, you find one here, whatever elements you have found, uh, this one wherever it was placed, remove, except that whichever is the maximum, place there this one. And if it happens that this one is moving, moving leftward to this one, so internally it is like this one is moving at this position and this is moving at this position. So yeah, thank you guys. I think we can code it up. Let me erase this code. So we'll try to code it up. We'll take long and initially score is 0. Okay. And we'll take n as the size of the vector and the size of the s, which are same only. We'll take one set and we'll store um, we can store only the maximum element, not pair. In the context I had stored it as pair, but here we can do it other way. We just need to store the maximum element. Now we'll iterate through this string, and once we are taking the element, first we need to put that in a set. So once you have found that, we have put in for each number we are taking, either it is 0 or 1 in s of I, so we are putting into set. Now we'll have to check if s of I is equals to 1, which means we have got a 1 and that one has to be placed somewhere in order to increase our score. So where do we put? So it's like we need to put at the position where the maximum element is present. So this set we can put we can make in decreasing order, sorted in decreasing order. So if it is the case, then we'll have to take uh, max value, and it is going to be star st dot begin. Okay. Now in score we'll have to add this maximum value, and once that element you have taken, so remove that element from the set. And when you come out of the loop, return score. I think there may be a multiple values. Okay. We may have multiple values as well. So for that case, like what I'm trying to say is, in an vector, we may have multiple values having same value. Let's say 10, 10, 10 multiple times. So in that case, it would be easier if we take pair only, like we will not just storing the value, we'll store the index as well. So it will make sure um, if we have same values, so we differ by index, so those multiple values are stored in the set. We can use multi-set also, but let us try this way. And okay, uh, but here your maximum value will be in first position because it is pair. In uh, first position we are storing the value, second position we are storing the index. Okay. And we need to erase the we need to erase that particular element because we have used it, so we don't want to put other element at that position. Let's try to run it and see. It is getting passed. Let's try to submit it. Yeah, it got accepted. So I think understanding the problem statement was here. You have to understand code. If you see, it is very simple, and if you try to analyze the time complexity, this will loop will take n, and your set will take log n to insert and to fetch. So time complexity is n log n, and space is like O of n. So I think you guys have understood. So if you did not answer, just comment. I'll try to help you out there. So I think it was an interesting problem. So yeah, thank you guys for watching the video.